Good morning children, welcome to today's session. I am Kalpana working as JL Zoology in COE GV Gudem, Nalgonda district. In today's session we are going to learn about mechanism of concentration of urine. That means how the urine is going to be concentrated, because in our previous class we have learned that from Bowman's capsule the filtrate which is coming is hypotonic urine, that means with less concentration, but mammals have the capacity to excrete concentrated urine or hypertonic urine. And the parts which are helping in concentrating the urine are Henle's loop as well as vasa recta, and the mechanism involved here is known as counter current mechanism. Counter means in opposite, current means flow. The flow of the renal fluid in the loop, Henle's loop, as well as the blood in the vasa recta are in opposite directions. They are very near to each other. Due to their proximity, a concentration gradient is maintained from cortex to medulla. If you take the osmolarity of both the liquids, it is going to be approximately 300 milliosmoles per liter in the cortical regions or in cortex, whereas if you go in deep into the medulla region, it is going to increase up to 1200 milliosmoles per liter in inner medulla. This concentration gradient is mainly due to movement of NaCl ions as well as urea. If you take the movement of the NaCl ions, they are moving out of moving into the interstitium from the ascending limb of the Henle's loop. From there it is entering into the descending limb of the vasa recta, and these entered NaCl ions again coming into interstitium from the ascending limb of the vasa recta, That means NaCl ions are maintained in the medulla region itself to maintain high osmolarity in the medulla region. And coming to urea, which is coming into the interstitium from the collecting duct and into the interstitium. From the interstitium, urea ions are entering into the loop, ascending limb of the loop of Henle, so that the concentration, the urea concentration as well as sodium chloride concentration is more in the medulla region. And if you take in the medulla region also, in the inner medulla it is going to be more, hence the osmolarity is going to be increased up to 1200 milliosmoles per liter in the inner medulla region. This interstitial gradient which is occurring in the medulla region is going to allow the movement of water molecules into the interstitium from the collecting duct, so that the concentration of the urine which is coming into the collecting duct is also going to be increased. That means at the final stage the urine which is going to be excreted is a hypertonic urine. And if you take the human kidneys, it is going to concentrate 4 times than the initial filtrate. Initial filtrate means the filtrate which is the renal filtrate which is coming out of the Bowman's capsule into the tubule, and it is going to become 4 times at the end of the collecting duct, or the excreted urine will be 4 times concentrated than the initial fluid. Children, question from today's topic is NaCl from ascending limb entering into the interstitium, from there into the descending limb of vasa recta, from there into the ascending limb of vasa recta, from there into the interstitium. That means here NaCl ions are continuously moving. If this doesn't occur,